Okay, so let's look at a different style of problem. So given an angle of interest and a radius, find the x and y coordinates at the point where the terminal side and the unit circle intersect and the slope of the terminal side. All right, so what we've got, find the coordinates of and slope to a point on the circle with an inclination of 2 pi over 7 and a radius of 9. All right, so the way that we need to interpret that, let's first draw a picture. So here's our unit circle. So we have an inclination of 2 pi over 7. So that means our angle of interest is going to be 2 pi over 7. And this distance from here to here is 9. And what we're looking for is we're looking for the x and y coordinate of that point. And the x coordinate is going to be r cosine theta, and the y coordinate is going to be r sine theta. Okay, and to find the slope of this line, okay, of the terminal side, the slope is going to be equal to the tangent of our angle of interest. So what we should expect is we can expect the slope to be positive because this line is going up and to the right. Okay, so this should be a positive slope. Okay, well, let's figure out what our x coordinate is going to be. So that's r cosine theta. R is 9, and we're doing the cosine of 2 pi over 7. So let's see what that's all going to be. So I'm just going to use the Texas Instruments calculator because on my screen, it's the easiest one to have open while showing you what I'm doing here on the right-hand side. So we just pretty much want to type this in as we see it. But we need to make sure, since we're dealing with radians here, that the calculator is on radians. And I think it's in degree mode because I see the words degree across the top. So let's hit mode. Yep, and it's in degree. So we have to change that to radians. There we go. Quit out of that. Okay, so we want 9 cosine of 2, and then pi is in blue here, so we have to go pi divided by 7. And we get 5.611. So that's the x coordinate right there. And I'm going to do a little trick here because I don't want to work with rounded values. So I'm going to store this in a variable in the calculator, and I'm going to store it in variable x because this represents our x value. So if I hit this store button, I can store my answer, and I want to put it in letter X. So you see how letter X is green? I can hit the green alpha button and put the letter X, and as soon as I hit enter, it's taken that value and it's put it in there as X. Okay, we'll call on that here in a minute. Okay, now we've got Y equals our sine theta. And so our radius is 9. Now it's going to be the sine of 2 pi over 7. So let's put that in just as we see it. So we've got 9 sine, oops, okay, 2 pi divided by 7. And we get 7.036. So the X and Y coordinates for that point are 5.611, 7.036. Now let me go ahead and store this value into variable y because this represents our y value. So I'm going to store that into, you see that capital Y in green. I'm going to hit 1, enter. Now it's stored that value in variable y on this calculator. Okay, so we've done half of this problem where we've calculated the coordinates. Okay, now we want the slope. So to find the slope, that's going to be tangent of our angle of interest, which is 2 pi over 7. So let's see what we get. So tangent of 2 pi divided by 7. Get 1.254. Okay, that is our slope of this terminal side. Now, let's just, for the sake of argument, if we wanted to calculate the slope as rise over run, which is the y value over the x value, which would be 7.036 divided by 5.611. What does that come out to? What I'm going to do, instead of typing all these numbers out or scrolling up and putting those in, remember I stored those in x and y. So I can just put y divided by x. And you see I got the same answer, 1.254. Okay, we expected the slope to be positive, and you can see that's positive, and that was positive. So it's kind of crazy to think, back in the day, this is how you calculated slope, which is correct. But now you can calculate slope, by just knowing the angle and using this tangent function. So it's even faster than what you've done before. Okay. So now that I've, shown you how to do it here, go ahead and give this a try on your own with this next think pair share. And I think maybe I'll use the numworks calculator for this one. That should still be shared. Okay, let me clear this out. Get that one ready. Okay, so go ahead and pause, give this a try. Resume if you need some help. Okay, so looking at this one, it says find the coordinates of and slope to a point on a circle and with an inclination of 5 pi over 9 and a radius of 18. Okay. Okay, so let's think about this for a minute. Now, we know that our angle of interest is 5 pi over 9. Okay, where if you kind of look at it, it's 5 of those pi over 9s. Okay, which means you're going to have like 8 divisions like this. Right? So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 divisions from 0 to pi, right? That's what that says. And so our angle is where we've got 5 of those pi over 9s. So our angle is going to be right up here. This is our angle of interest. It's in quadrant 2. All right, so in quadrant 2, we need to expect that our x value will be negative, but our y value will be positive, right? Because over here we have positive x, here we've got negative x, up here we've got positive y, and down here we've got negative y. So we should expect our x value to be negative, and we should expect our y value to be positive. Okay. Okay. And just like before, our x value is going to be equal to the radius times the cosine of our angle. And we were told that the radius is 18. So we're going to have 18 times the cosine of 5 pi over 9. Now again, we should expect this to be a negative value if we've done it right. So let's take a look at that, but we're going to use the numworks calculator, which is going to kind of cover up the screen here for a minute, but that's okay. All right, first of all, let's make sure that this is in radian mode. So to get down to settings, when you're in this menu screen, you can hit 0 and 0 again. That's a good shortcut to get right into your settings, 0 and 0. And so you can see we're in degree mode. Oh, and I guess I should have noticed up here in the left-hand corner, it says degree mode. Okay, so that tells us we need to change it to radian. So I'm going to click OK, change it to radians, click OK, and then I can hit home. And I think I can hit 1 and 1. Okay, because the calculation app is the first one. So you can, when you're in that home menu, if you want to go to the first app, you just hit 1 and then 1 to go into it. Okay. All right. So what we need to do is we need to put 18 cosine of 5 pi over 9. So 5 pi divided by 9. And we will do that and execute. Okay, so we get negative 3.125 or negative 3.126. Okay, so let's come back. So we get negative 3.126. And we expected our x value to be negative, so that's good. But before we continue, let me show you how to store this variable or this value into a variable. So you'll notice on the numworks screen, let me see if I can make this a little bit bigger. There you go. On this key, there's a little orange arrow, and the orange arrow is pointing to the right up here in the corner. That's the numworks version of storing a value. Okay. So if you want to take your latest answer and store that in a variable, you can hit the orange shift button followed by this button. And so it's going to take the answer and put it into, and you can see we want to put it in this variable x. Now, what's kind of nice about the numworks calculator is you can store it in a lowercase x or an uppercase x, a lowercase variable or an uppercase variable. So just to keep it simple, I'm just going to use lowercase. So to do lowercase, I just have to hit this alpha button And you can see the word alpha is in lowercase here, and then the number 2, and it's going to put it in lowercase x. So I'm going to hit execute. There. So it just put that value in x. Okay. Now let's come back. So now we've got y equals our sine theta, which is 18 times the sine of 5 pi over 9. Now we expect this one to be positive, but let's just check. So here we're going to have 18 sine of 5 pi divided by 9, and we get 17.727. 17.727. It's positive, so that's good. And let me go ahead and store this value. So again, it's this orange arrow pointing to the right. So I have to hit the orange shift button, followed by this one. And I want to store that now in Y. So there's Y. So alpha 3, execute. Okay, there it is. And now we want to calculate the slope. So the slope is going to be equal to the tangent of that angle. Now we expect that the slope is going to be negative because the terminal side is going up and to the left. So the terminal side is going up and to the left. So that means it's going to have a negative slope. Okay, so let's do tangent of 5 pi over 9. Yeah. Okay, so tangent of 5 pi divided by 9. We get negative 5.671. So negative 5.671. So that's equal to the slope. And let's just check that. We know that slope should be y over x. And if we do that with our calculator, using the variables that we stored, we can do y divided by x, and we get negative 5.671. Okay, so that just kind of validates, what we did here. Okay, all right. Let me know if you have any questions.